Today we will be doing identifying concavity, increasing, decreasing intervals, min, max of polynomials. So if you remember, we did cover this a little bit ago. This is just more of a review, and this is more talking about polynomials. We were talking about quadratics, now we're going to be talking about polynomials. Polynomials is any degree other than, I guess squared is also one, but it's just any degree. It can be squared, cubed, to the fourth, to the fifth, whatever. It can be to anything. So this is an example. The instructions said to draw a polynomial function that's concave down and increasing on an interval, and then concave down and decreasing, and concave up, and so forth. So we're going to follow these instructions. It will help you if you write it down. If you don't want to write it down, it doesn't matter. You don't have to write out the whole thing like I did. I just needed everybody to be able to see the example. So if it's concave down, remember concave, and I'm going to use pencil just so that I can erase it. Concave down on the interval. So concave down looks like this. Oops, that's not dark enough. So this is concave down, and then this is concave up. So concave up and concave down. So if you look at concave up, we're talking about down first. So if you look at this concave down, this part is increasing and this part is decreasing. So that's how you can have two parts of concave down, one part being increasing, one part being decreasing. So it says concave down and increasing on the interval from -∞ to -4. Remember, these are talking about the x value. So we don't care how high up. It doesn't tell us how high up. It just tells us it's increasing from -∞, so back here, to -4. So all back here, it is concave down, so it's going to be like this, and it's on the increasing side, so it's this side of it. So we know, and it doesn't matter where you put your point, I'm just going to put it there. That's at -4, 1, 2, 3, 4. Now I'm going to put it at 3 just because I don't want that 4 to be confused. So it doesn't matter where. And then it's concave down, so concave down but decreasing, so it's this side of it, from -4 to 2, 1, 2. So it's going to have this form to 2. So let's do 2, -2. And then it says concave up and decreasing on the interval to 7. So 2 to 7, so 7 is right here, and it needs to be concave up, decreasing. So I'm going to go ahead and just draw the general idea so far. So concave down, increasing, concave down, decreasing. Then it says concave up and decreasing. So if you look at that, and then it's concave up, decreasing. So concave up looks like this and decreasing. So I need it to actually go down. So it's going to keep going down from 2 to 7. And then it's going to be concave up, increasing for the rest of it. Okay, so I'm going to draw this line a little bit better just because I had gotten to that point. So concave. Okay, so I'm going to talk about that again. I'm going to look over all of the parts of it. So concave down, I'm going to go ahead and color all of this concave down and increasing. So this is concave down and increasing, concave down and decreasing is to this point. Can't really tell if that's purple, but it's okay. And then concave up, decreasing, and then concave up, increasing for the rest. So remember where it changes, this is where it's changing from concave down to concave up. So that's actually called, this point right here is called the inflection point. An inflection point is when the function, I'll flip it over, changes from concave up to down or vice versa. So you should have that in your notes, but I just wanted to go ahead and write it. So the inflection point is where it changes. So it's no longer concave down, it's now concave up. Okay. And these are weird. You will have one on your assignment that's like this, where it's talking about concave up, concave down, an inflection point. So inflection point, remember, like I just said, that's where it changes from being concave up to being concave down. Okay? Now we're going to do an example from looking at the calculator. So if I have y equals 1/3 x cubed plus x squared minus 3x. Okay, go ahead and type this in. So 1/3 x cubed. Make sure to always hit the over arrow so that it comes down out of the exponent. Graph. Okay, so first thing you need to talk about is the concavity. So it is concave. If you look at this first part, from that part right there, don't look at this part over here. So that is concave down. And you can see that it's concave down from negative infinity. Let me get an expo marker. So it's concave down over here. So from negative infinity, remember that just keeps going. And then it switches, that's that point where it switches from being concave down to being concave up. So that's that inflection point. So it looks like it's at 1. So it's concave down from negative infinity to negative 1. And it's concave up from 1 to infinity, or from negative 1 to positive infinity. Remember, you always put the smaller number first, saying that it's going from 1 to infinity. And then it wants you to talk about when is it increasing or decreasing. So it's increasing. So on your worksheet, it's going to give you equations like this. It's going to ask for the concavity. It's going to ask for when it's increasing and decreasing. And it's going to talk about min and max. So if you look at this one, it's definitely increasing from, and I'm just going to highlight all the parts it's increasing. So it's increasing that part's decreasing, and then it's increasing again. So the easiest way to do this, I'm going to zoom in just so that you can see my marker a little bit better. Actually, I'm going to get a different marker. See if this marker works better. Yeah, there we go. I don't remember what I was going to say, sorry. So look at when it's increasing. So if my marker is going up from left to right, then it's increasing, that's increasing as well. So it's increasing. So it's increasing from negative infinity to, that looks like negative 3. Oh, you couldn't see me do that. So I said from negative 3, because that's where it stops. And then it's increasing from right here, so that looks like 1 to infinity. That's a terrible infinity sign. Okay, so that's when it's increasing. Now let's look at when it's decreasing. Well, it's going to be that interval in between. So from negative 3 to 1. So it is decreasing from negative 3 to 1. Okay, the function is always either increasing or decreasing. I guess the only time it wouldn't is if it was just a straight across line. But typically you should have all intervals covered. So from negative infinity to negative 3, it was increasing. Well, then it's going to switch to decreasing, so negative 3 to 1. And then from 1 to infinity, it increases again. Okay, now the last thing that you need to talk about are your min and maxes. So if you look, there's a point right up there. There is a point. Remember, min, max is not an interval. It's actually the point at which it's the min or the max. So this point is a max because it's the highest. Now, it is not a global because there is a part. So if you look at this point right here, there is a part that's higher. So it is not a global max, it's just a local max. And then it's at negative 1, negative 2, negative 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's at negative 3, 9, and it's a local. And then we have a local min, because same thing, it's not the lowest point of the entire graph, it's the lowest point of just that part. And it's at 1, comma, let me move my cursor, 1, 2, negative 2. So that is everything about your graph. Notice I talked about when it's concave down, when it's concave up, when it's increasing, when it's decreasing, what the local max, what the local min is. So those are all of the pieces of information you're going to need on your assignment. Okay. Remember, local max and local min you can find by using that second trace. All of these are going to be estimates, so like if it looks like it's not exactly at negative 3, just round it to negative 3 on your assignment.